Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use the half reaction method of balancing redox reactions in acidic solution. So let's get into this. So the first step you want to take is to identify what the oxidation states of every atom in every compound is. Now in this equation we have solid aluminum reacting with aqueous copper 2 ions, and that's going to form aluminum 3 plus ions, and then we get solid copper. So no compounds, just elements and ions. So what we need to do is determine what the oxidation states are. So for elements in their standard states, the oxidation state is 0. So copper solid is in its standard state, so that's going to have a 0 oxidation state. Same with aluminum, that's also going to have 0 for its oxidation state. And then for monatomic ions, the oxidation state is the charge on the ion. So here we have aluminum 3 plus, so the oxidation state for this aluminum atom is the charge 3 plus. And for copper, the oxidation state is 2 plus, because that's the charge on the copper ion or atom. So that's, now that we have the oxidation state set up, we can figure out what is undergoing oxidation, what's undergoing reduction. And what's going to help us here are these mnemonic devices. So either you could use oil rig, right? So oil stands for oxidation is loss of electrons, and reduction is gain of electrons, right? So you can remember which one is which by that mnemonic, or if you want to use Leo Ger, Leo the lion goes Ger, right? So again, it's going to be loss of electrons is oxidation. Gain of electrons is reduction, right? So either mnemonic works, whatever you want to use. But now that we can use these, we can figure out what's going on here, what's reduction, what's oxidation. So what we're going to do is we're going to divide up this equation into two half reactions. This reaction is going to be divided into two halves. We're going to have the oxidation half, and then we're going to have the reduction half. So oxidation, oil, oxidation is loss of electrons. So we're looking to see what lost electrons. If you lose electrons, that means you become more positive. So here aluminum is 0, and then it becomes 3 plus. So it became more positive. It lost electrons, so it underwent oxidation. So we're going to write the half reaction here. So aluminum solid goes to aluminum 3 plus. Okay, so and then we do the same thing with the reduction. Reduction is gain of electrons. If you gain electrons, you become more negative or less positive. So which one became less positive? We have copper 2 plus, and it goes to 0, became less positive. So that is reduction. So we're going to write the half reaction. So Cu2 plus aqueous. And I should put aqueous here. We don't want to forget the states. And that's going to go to Cu solid. Okay, so now we have it divided up into our two half reactions. So that's step 2. Then now step 3, what we need to do is balance our half reactions separately. And the first thing you want to do is balance the mass. So balance the atoms on both sides. This one's really easy because the atoms on both sides are equal, right? So we have one aluminum, we have one aluminum. Here we have one copper atom. So both of them are balanced in terms of mass or atoms. And now the next thing we need to balance, step 4, we're going to balance the charges. And we're going to balance the charges by adding electrons. Okay, so we have a positive 3 charge here. We have 0 charge on this side. So to balance a charge, we're going to add electrons. We can only add electrons. So since we have 0 here and our electrons are negative, we got to add it to the side that's going to help us get the balance. So we have a positive here. So I'm going to add 3 electrons to this side, because if I add 3 negatives to this side, that'll balance the 3 positives, and then I got neutrality on this side. So neutral, neutral. Okay, same thing with here. I got 0 on this side. I have a +2 on this side. So I'm going to add for this one to this side, I'm going to add 2 negative electrons. So 2 negative electrons plus the +2 gives me 0. That's going to balance with 0 charge on this side. Okay, so now that I've balanced the atoms, I've balanced the charge. Now at this point, I need to make sure before I add these two halves back together, I need to make sure that the electrons cancel out. You'll notice I have 2 electrons on the reactant side for the reduction half reaction, and I have 3 electrons on the product side for the oxidation half reaction. But I want those to cancel out. So when I add, the products and reactants cancel out. So, but I have 2 and 3, so that's not going to cancel out. So I need to multiply each half of the reaction by a factor that's going to give me equal number of electrons. So if I multiply this equation by 3, I'll get 6 electrons. And if I multiply this equation by 2, I'll get 6 electrons. So let's go ahead and do that. So I'm going to multiply this by 3. Oops. Let me make sure that's clear. So I'm going to multiply this by 3. And then this equation, I'm going to multiply by 2. So then I get 2Al solid goes to 2Al3 plus aqueous, and then plus 6 electrons, because 2 times 3 is 6. And then for the reduction half reaction, 3 times 2 again is 6 electrons, plus 3 times that, I'm going to get 3 copper 2 plus aqueous. And then I'm going to get 3 copper solid, so 3 CuS. So now I have both half reactions here. So the half reactions both have 6 electrons. 6 on the product side here, 6 on the reactant side. So when I add these together, these 6 electrons on both sides will cancel each other out. So then this is going to cancel out with that. I add these back together, and I'm going to put the reactants, both reactants on the same side, both of the products on the same side. So then I get 2Al solid plus 3 Cu2 plus aqueous. That's going to go to 2 aluminum, 3 plus, and then I have 3 Cu solid. And so at this point, you can see that we now have a balanced redox reaction, and you can double check to make sure everything balances out, that both sides have the same amount of charge. So here I have 3 times positive 2 gives me a positive 6 charge on this side. 2 times 3 gives me a positive 6 charge on this side. These are neutral, so I don't need to worry about those. And the number of atoms are balanced. 2 aluminums, 2 aluminums, 3 copper, 3 copper. So this is a balanced redox reaction in acidic solution. So this is a relatively easy one. The fact that it was in acidic solution didn't really factor into this one, but it will factor in the next problem I do in the next video. So I hope this is helpful. I hope this was insightful and engaging. And if you enjoyed this video, then please, by all means, like the video, hit that like button, share it with your friends, and also make sure you hit that notification bell, subscribe to my channel, and then when you hit the notification bell, hit all so you can be notified by all the videos I put out. And also put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.